Salam and welcome everyone. So today we're going to be working on the question on the screen that says, given that the standard enthalpy of formation for HCl aqueous is negative 167 kilojoule per mole, what is the value for change in enthalpy of formation for chlorine ion aqueous? So of course you've seen that we're dealing with the standard enthalpy of formation of HCl. So we've been given the molecule or the compound, right? And we're told the standard enthalpy of formation. So standard enthalpy of formation for HCl aqueous is negative 167 kilojoule per mole. Then we're now asked for the value for the enthalpy of formation for chlorine ion aqueous. So basically, this is it. So we're asked to determine this. Well, since we're dealing with standard enthalpy of formation question and we've been given a molecule and an ion, we're just first of all going to write the chemical equation. So the chemical equation for this is just simply H plus aqueous, okay, plus Cl minus aqueous, okay, would give us HCl aqueous. So this is basically how you do write out the equation. And yeah, we start to solve. So the first thing you have to note is this. Whenever we're determining the standard enthalpy of formation for molecules, all of this is usually done in the laboratory at 298 Kelvin. So that is how we calculate it. But that is for molecules. Whenever we're dealing with ions, it becomes tricky. And the reason is because ions, of course, are have positive and negative charge. Here, H plus is a cation, okay, and chlorine minus is an anion. And this is much more difficult for us to calculate because we cannot separate the H plus ion from the Cl minus ion and then determine the enthalpy, the standard enthalpy for each one of them at 298 Kelvin. Because anytime you have an aqueous solution, you always have to have the cation and the anion. But unlike separating molecules, you cannot separate ions because the ions that would make up the aqueous solution. So what we have to do is that we have to define one of the standard enthalpy of formation for one of the ions and give it a set value. And usually whenever we do that, we set the value for H plus generally to equal 0, because when we set this to H plus equal 0, then we can simply determine the standard enthalpy for the other ion, and in this case the chlorine ion, which is basically what we're asked to do. So the standard enthalpy of formation for chlorine ion, right, for chlorine ion is going to be what? Well, because we have a 0 here and then we have this to simply be you have this to simply be 167. When you force this value to 0, the answer for the standard enthalpy for the other ion, in this case chlorine ion, is just simply going to take the same value for the molecule. So that is how it's done. So this would end up making our standard enthalpy of formation for chlorine ion to actually be the same value for the standard enthalpy for the HCl. So yeah, so negative 167 kilojoule per mole. So yeah, that's basically how we do it. There is no solution, there is no calculation, there's just an understanding of concepts. So for those of you who want better understanding of this, I'm just going to write to you a short information. So if you're asked this question in, I don't know, a test, an assignment, or exam, you can just write this answer I'm about to give you. And this is using the physical chemistry Atkins 11th edition as a guide, because that's how you solve a question like this. This is actually a question from the guide itself. So you write the standard enthalpy of formation for Cl minus aqueous is also negative 167 kilojoule per mole. This is because we cannot prepare a solution of cations separate from a solution of anions. Therefore, sorry, this is so wrong. So therefore, we cannot easily determine the standard, basically what I had explained earlier, the standard enthalpy of formation for any ions. We cannot easily determine the standard enthalpy of formation for any ions. To solve this, to solve this issue, we define the standard enthalpy of formation for one ion generally the hydrogen ion to become 0. So what this is saying is that we're going to fix the standard enthalpy of formation for one of the ion, usually the H plus ion. We're going to fix it to become 0. When you do that, so to solve this, we define the standard enthalpy of formation for one ion, generally the hydrogen ion, to become 0, while the other ion has the standard enthalpy of formation of the compound ascribed to it. So yeah, concept-based question has a concept-based answer. So lastly, change in standard enthalpy of formation for the compound or the molecule HCl aqueous is going to equal the change in standard enthalpy of formation for chlorine ion aqueous to simply become negative 167 kilojoule per mole. So basically, this is the answer to this question. This is just a concept-based question for you to test whether you're studying and understanding the concept or not. So this is how you solve it. I have done question B for this same question style in another video, so make sure you watch that video next. Everything you need is in the description box. Now, I wanted to mention that if you're a student who is struggling in any of your STEM related courses, whether you're in middle school, high school, or college, make sure you email me at shahabitutoring@gmail.com. I help students succeed in all your STEM related courses as well as mentor them through their academic life. So yeah, if you need any help, do not hesitate to email me at shahabitutoring@gmail.com. I'm excited to work with you guys. I wish you guys all the very best. Assalamu alaikum wa rahmatullahi wa barakatuh.